All right, so the purpose of this video is to discuss physics classroom EC12, and I'm going to go through some of the ones that I've had the most common questions on this, and we'll go in order as we go down through it. This first one is Q4. I got a lot of questions here, and this has to do with, it says a resistor, it gives us a number, tells us what they are connected to an 8.2 volt battery. 8.2 volt battery. And then it wants to know the voltage across, the voltage drop. What is the voltage here? And what is the voltage here? What is the voltage drop? That's supposed to be a question mark there. What is the voltage drop across both of those? And this is actually where we need to go back to our circuit theory, and when we think about Kirchhoff's loop rule, where whatever the battery does, and in this case it's raising voltage from 0 down here to 8.2 volts here. That 8.2 volts, as it travels in a path back around to 0, has to all get subtracted away. So in this case, since an individual charge would travel only through this resistor, all of that 8.2 volts there, so this voltage would be an 8.2 volt drop across here. Likewise, in a different charge, it would pass through just this resistor. So likewise, it would be the same voltage as well, 8.2 volts. That's how you would complete question 4 on there. Another very common question I see is on this one. This one gives you some numbers, but really, I think it's just helpful to know. What it's trying to say is the water that's flowing in here at A is the same water that's flowing out here at D. So what you can say is the water at B and C are not necessarily equal, but they for sure add up to what's at A and D. So on EC12, the question I think I saw the most when working on this is this circuit right here. And this is definitely a difficult question. It gives you this circuit, and over here, maybe a little bit hard to read, but it says the resistance at resistor 1 is 11.4 ohms. Put it right here. Resistor at 2 is 2.7 ohms. It tells you the current right down here is 7.2 amps. And ultimately, it's wanting to know what is the current here? Well, what is the current here and here? To do this, you just use your friendly old equation for Ohm's law. The easiest is if you just state it as voltage equals current times resistance. And you have to look at it from a couple different angles before you can really solve it. If you're looking for here, and you say, well, if I want to solve for current right here, I can use this equation. So if you say V equals I times R, you know resistance is 11.4. You don't actually know what I is. That's what you're wanting to know. And you don't know what V is. So this is a dead end right now. We can't just look at this microscopically and solve it. You're going to have to back out more from a macroscopic view and look at the whole thing and see what you can solve. So the question is, could we solve the voltage drop that would take place from here over to here? What does this voltage equal? Which would actually also be the same as this voltage right here, because hopefully by now you've understood that. So the voltage from here to here, what does that equal? Well, that's going to be the same as this voltage of the battery, because these are in parallel. Well, to do that, we use Ohm's law. Voltage equals current. We actually know the current, so we can start putting in what we know. 7.2 volts times R. Now, here's a problem. Well, we don't really know what R is. Well, you can figure it out, though, because R is going to be in this total thing. It's going to be R total, and that's going to be the total resistance from here all the way around. And so we have two resistors here in parallel, so we would use our equation for resistors in parallel. That equation says R total, 1 over R total equals 1 over R1 plus 1 over R2. So we could find our total resistance. What that would say is 1 over R total again equals 1 over 11.4 plus 1 over 2.7. So just a little calculator trick on this. You can, to do this equation. So a trick here is you do 11.4 inversed plus 2.7 inversed equals, and then you get the inverse of that. And that's going to be your total resistance. Well, now you can put that in up here because you found that. So it would be voltage is equal to 7.2 times 2.18 times 7.2. Well, here we know our voltage is going to equal 15.72. I'm rounding volts. Well, that's what this is. And that's also what this is. And if you understand circuit theory and the way that voltage drops work, you would know then that the voltage across here and the voltage across here is also equal to this. They're all equal, as we previously stated. So that would be 15.72. So now, when we started this before, now we have a voltage. We can add that to our equation. So we can put 15.72 is equal to current times 11.4. Of course, we can divide both sides by 11.4. And we can get 1.379 is equal to current at that point. And that would explain how to do that when you would do the same thing over here. Thank you. Like and subscribe.